Hey everyone, welcome back to The Explainer. I'm so glad you're joining us today because, honestly, we're diving into something pretty fascinating. We are demystifying exactly how our digital world physically connects. Think about it. Every email you send, every video you stream, every multiplayer game you dominate, it all relies on the physical and logical architecture of networks. Today, we're popping the hood and taking a closer look.
Have you ever actually stopped to wonder how all these devices talk to each other? It's kind of like a massive, invisible puzzle that needs solving. We so seamlessly send data across rooms, buildings, and even continents. But right beneath that seamless experience is a complex web of cables, switches, and routers forming invisible highways. And how we lay out those highways? Well, that changes absolutely everything about how the traffic flows.
All right, let's just jump right in. Here's our roadmap for this explainer. We're going to map out the basics, then we'll build up our networking tool belt by checking out three distinct tools: the star topology, the mesh topology, and the hybrid topology. After that, we'll throw them into an ultimate showdown and finish up by testing your new skills with some real-world scenario design. Sound good?
Let's get our foundational concepts locked in first. Section 1, Mapping Network Basics, Understanding the Layout.
So our golden term for today is network topology. Simply put, this is how devices and links are arranged in a network. But wait, it's not just the physical layout, like where you actually plug the cables in. It also covers the logical path that data follows as it zips from point A to point B. And let me tell you, the choices a network architect makes right here, they're absolutely crucial. This stuff directly impacts transmission speed, fault tolerance, scalability, and, the overall cost. Choose the wrong layout, and your network might just become an expensive, crawling mess.
All right, let's pull the first specific tool from our tool belt. Section 2, the star topology, the central hub.
Now you can probably guess exactly why it gets its name. Every single device, whether that's your laptop, a desktop, or that printer in the corner, connects individually to a central switch or hub right in the middle. So when your computer wants to send a message, it doesn't just shoot it directly over to the printer. Nope, the message travels from the sender straight to that central device, which then acts like a traffic cop and directs it out to the right destination. It's literally like a bicycle wheel with all the spokes meeting right at the hub.
But, as you know, every engineering choice has its trade-offs. On the plus side, the star topology is super easy to manage and expand. Want to add a new computer? Easy, just run one cable to the central switch. Plus, if one cable accidentally gets cut, only that single device drops offline. The rest of the network keeps happily humming along. It makes finding faults a total breeze. However, and this is a massive however, that central device is a critical point of failure. If the central switch loses power or breaks, boom, the entire network drops dead instantly. Also, because every device needs its own dedicated wire running all the way to the center, it requires a lot of cabling, and your costs are for sure going to rise as you need larger and larger central switches.
So, what happens when we absolutely positively cannot afford for the network to go down? That brings us to Section 3, the mesh topology, ultimate reliability.
Take a look at the sheer amount of redundancy here with all those intersecting links. This is the mesh topology. Instead of relying on a single middleman, nodes have multiple direct paths right between them. It honestly looks a bit like a giant spider web, doesn't it?
Because of all those intersecting lines, the mesh topology offers crazy high redundancy and reliability. If one connection fails, heck, even if a whole device goes down, the data just shrugs, reroutes, and finds an alternative path to its destination. It is incredibly robust, making it perfect for supporting critical services. But, I bet you can guess the downside. All those connections mean a massive amount of expensive cabling and hardware. It's way harder to install and maintain. Now you could do a full mesh, where literally everything connects to everything, or a partial mesh to target just the most critical nodes and save some cash. But either way, you're rarely going to see this in a small home network because the cost just completely outweighs the benefit.
Okay, what if we want the reliability of a mesh, but the management ease and cost effectiveness of a star? Enter Section 4, the hybrid topology, the best of both worlds.
A hybrid topology combines features of two or more different layouts into one larger design. Picture a massive university campus. Inside a single classroom building, it makes perfect financial sense to use simple, cost-effective star networks. But if you need to connect the engineering building over to the library and the main server room, you might link those main hubs together using a highly resilient mesh pattern. You are literally combining the puzzle pieces to fit the exact physical and logical needs of the organization.
So,
The really crucial point here is that hybrid designs aren't just thrown together randomly. They allow an architect to perfectly balance performance, reliability, and budget by tailoring different sections of the network to specific jobs. This makes it insanely scalable for huge organizations. The trade-off? Complexity. You need a seriously skilled engineer to design, plan, and troubleshoot a hybrid network because you've got multiple different architectural rules operating all at the exact same time.
All right, we've got our 3 tools. Let's put them in the ring for Section 5, the ultimate showdown, comparing the topologies.
Weighing their specs side by side in this grid, the strengths and weaknesses really pop out, right? For reliability, Mesh is the undisputed heavyweight champion because of those alternative paths. Star is good but definitely vulnerable at the center. For cost, Star gives you solid, moderate value, whereas Mesh, yeah, that's going to heavily drain your budget. When it comes to data collisions, both Star and Mesh actually keep them pretty low. And finally, for sheer scalability across large environments, the hybrid topology easily takes the crown. It adapts beautifully as an organization grows.
Let's move on and see how this all builds into practical applications in Section 6, Real-World Scenario Design. I'm going to give you a scenario, and I want you to put your network architect hat on and decide which tool from our belt is the right choice.
First scenario for you. You're designing a network for a huge hospital or a critical 911 dispatch service. Lives are literally on the line, and if the system drops, the consequences are disastrous. What topology do you choose? If you said mesh or partial mesh, you hit the nail on the head. In a hospital setting, reliability is the absolute top priority. The high cost of installing all those extra cables and hardware is totally justified because backup paths reduce the risk of failure to near zero. Uptime here is quite literally a matter of life and death.
Okay, let's scale it way back. Scenario 2. You're setting up a network for a standard home or maybe a small real estate office with about a dozen folks. Budgets are definitely tighter, and you don't have a dedicated IT team on staff. What's your play?
The clear winner here is the Star topology. It offers brilliantly low costs. It's incredibly easy to just plug a new device right into the central Wi-Fi router or switch. And managing it is super simple. It perfectly balances your budget and performance for everyday internet use without overcomplicating things.
Final scenario, and it's a big one. You've been hired by a massive government department or a sprawling corporate campus. You've got multiple buildings, varying levels of classified security needs, and a wild mix of heady data servers and basic clerical computers. What do you build? You build a hybrid topology. Large, complex organizations require a deeply resilient, heavily protected core network, like a mesh linking the critical data centers, blended with simpler, cost-effective Star endpoints for the everyday office workers. A hybrid approach perfectly balances scale, security, and uptime to maximize value across all those different departments.
Before we wrap up, let's rapidly bust a few common misconceptions that always seem to trip people up. Myth number 1. Mesh is always best. False. It's the most reliable, sure, but for most everyday applications, it's drastically over-engineered and way too expensive. Myth 2. Star has no weaknesses. Actually, scratch that. Remember that central switch is a massive single point of failure. And finally, myth 3. Hybrid just means a random mess of wires. Absolutely no way. A true hybrid topology is a highly deliberate, strategically planned combination chosen to meet exact organizational needs.
You now have a really firm grasp on the physical and logical ways our world is wired together. As we finish up this explainer, I want to leave you with a quick thought exercise. Imagine your local college campus is expanding, adding a brand new building that houses critical exam servers that absolutely cannot go offline, while the rest are standard classrooms. Thinking about reliability, speed, and cost, how exactly would you design that hybrid network to guarantee those exams never drop? Keep looking closely at the invisible networks all around you, and I'll see you in the next explainer.